Hello viewers, you are welcome back to Tyndanius Maths and Science tutorials. Today we are going to consider physics, and of course we are going to relate physics in medicine, hence medical physics. We started with pressure a long time ago, but this time around we want to take one or two questions to appreciate it more and more. If this is your first time, you kindly subscribe, comment, like and share as well for more interesting videos. So here I have neglecting the pressure drop due to resistance. Calculate the blood pressure in millimeters of mercury given this relation. 1 millimeters of mercury equals 133.34 Pascal in an artery in the brain, 30 centimeters above the heart. The pressure at the heart is 20 millimeters of mercury and the density of blood is 1.05 gram per centimeter cubed. Assume acceleration due to gravity is 9.81 meter per second squared. Using the same assumptions, calculate the blood pressure in an artery in the foot, 1.6 meters above the heart. Viewers, this is so interesting because it is related to your health. Your health should be your priority. Now, before I throw more light on this, I would want us to know certain one or two stuff, which is of course a basic concept we are going to employ in solving this. First of all, if there is a relationship between the pressure of the brain and the pressure of the heart, and we also have the relationship between the pressure of the brain and the pressure of the foot or the leg. So, if I know the pressure of the heart, P heart, where P is your pressure, then I subtract the normal pressure due to a particular height or pressure due to a particular depth. And the pressure due to a particular depth or height is given by rho H G, where rho is your density, H is your height or your reference level, and G is your acceleration due to gravity. So if you are able to subtract this pressure from the pressure of the heart, you will get the pressure of the brain. This is one important equation you should take note of. Again, this one, if I have the pressure of the heart being added to the pressure due to depth or a height, if I add them, this one I'll get pressure of the foot or pressure of the leg. So this is another important equation you should understand. Alright. So let's solve the question. So let's write our data down. We're given this relationship. 1 millimeter, that's 1 millimeters of mercury is equal to this in an artery in the brain, 30 centimeters above the height. So this talks about height or distance. So let's say my H here is my 30 centimeters, which is the same as what? 30 by 10 raised to the power what? Negative 2 what? Meters. Then I have the pressure at the heart is 20 millimeters of mercury. So I have pressure of the heart to be equal to 20 millimeters of mercury. So before I proceed, I'll have to convert this into Pascal. Then we proceed with that. So given this relation, we are given this relation because we want to change this millimeters of mercury to its respective SI units. So I'll say if 1 millimeters of mercury equals 133.34 Pascal, then the pressure of the heart, which is given to us by, I think, 20 millimeters of mercury, becomes what? If more, let's divide. So I'll have 20 by 133.34 Pascal. So therefore, the pressure of the heart in Pascal should give us this value, 16,000.8 Pascal. Alright, so this is it. Alright, so again, we're giving, and the density of blood is 1.05 gram per centimeter cube. This is not the SI unit you want to work in. You have to work in kilogram meters per second, per cube, sorry. So I know that 1 gram per centimeter cube is equal to 1,000 kilogram per meter cube. By the question, we are giving the density of the blood to be what? 1.05 gram per centimeter cube. So I will simply multiply this by this to convert it to kilogram per meter cube. So the pressure, so that means the density of the blood is given by 1.05 by 100,000, which is equal to, so I have 1050 kilogram per meter cube. Alright. So viewers, this is the data. Alright, so let's see how we can do our substitution over here. The question reads, so here we are supposed to calculate the blood pressure in an artery in the foot. That is one. And also, we are supposed to calculate the blood pressure in millimeters of mercury in an artery in the brain. So here we need what? The brain pressure. You also know what? The pressure of the heart. So what is the relationship? We know that the pressure of the brain equals, so the pressure of the heart minus my rho g what h. I know the pressure of the heart, which is equal to, that has been calculated over here in Pascal, please. I have the value over here, which is equal to, I have my 160.0.8 minus then rho, that is the density of the blood. So density is equal to what? I have this 1050 times the h, which is the height. In the question, I have it to what? 30 centimeters or 0.30 meters. So I have 30 times 10 to the power negative 2, then times my gravity. According to the question, take gravity to be 9.81, not 10. So I have 9.81 over here. So therefore, the pressure of the brain becomes, by the help of the calculator, we are getting 12910.65 Pascal. But viewers, if you end over here, you may be penalized. Why? Because the question says, calculate the blood pressure in millimeters of mercury. So again, you are going to employ the relation given to convert it back to what? To millimeters of mercury. So if you want to change this to millimeters of mercury, millimeters of mercury, so by simple proportion, so this becomes, so we know that 1 millimeters of mercury is giving us 133.4 Pascal. And this time around, I have this 12910.65 Pascal. So what is the pressure in millimeters of mercury? So this is what? More. So if more, let's divide. So I'll have 12910.65 over this 133.4. So if I have Pascal here, then times what? My 1 milliliters of mercury. So therefore, the pressure developed in the brain is equal to, by the help of the calculator, you should be getting 96.83 millimeters of mercury. Viewers, the concepts are very simple to understand. So this is the first part of the question. And the second part is saying, using the same assumptions, calculate the blood pressure in an artery in the foot, so the leg, alright? So you already know that the pressure developed in the legs should be equal to what? The pressure of the heart, then plus rho Hg. So we are sticking to the same assumption. So pressure developed in the legs, we have the pressure of the heart already expressed in Pascal, which is over here. So I have 16000.8 plus, then my rho. What is my rho over here? So calculate the blood pressure in an artery in the foot, 1.6 meters. So density, so I have the density here. In its respective SI units. So I have 1050, then times the height. I'll be very careful. Because the person said you are sticking to the same assumption doesn't mean everything here will be duplicated over here. Here it said an artery in the foot, that's 1.6 below the heart. 1.6 below the heart. Get it? So that means from my heart level to my foot or the leg. This is the distance made, which is what? My 1.6 meters. It's already expressed in its SI unit, so I don't need to do any conversion. Then times, sticking to the same assumption, gravity still holds, which is my 9.81. So by the help of the calculator, when you compute this, you should be getting 3,220. That's 32481.60 Pascal. Alright? Note that we are supposed to change this in millimeters of mercury. So what do? I will simply divide this by this to simply convert it. You can use proportion as we did over here. We wanted to change this to millimeters of mercury, so we just divided this over this, just change it to millimeters of mercury. So we can do that over here. So the pressure in the legs or the foot is 32481. That's 3,240. Is that 1, 2, 3? Yeah, so 32,481.60. All over, I have 3.34. So by the help of the calculator, when you compute this, you should be getting 243.60 millimeters of mercury. Viewers, this is the end of the tutorials. It's very simple. So far as this YouTube channel is concerned, we will bring more interesting topics concerning your health. This is one application of physics. Remember to subscribe. Bye.